Friends, good morning to everyone. We were dealing with photochemical reactions. Today's subject of discussion is photo addition reaction. As the name indicates, this is an addition reaction which is induced by light. Basically, addition reaction is a bimolecular reaction, means it includes two molecules. When one molecule gets added up onto the other, it is addition reaction. And this bimolecular addition takes place in the presence of light. That's why it is photo addition reaction. Here, two molecules combine together to give a single product. Here also, like another any photochemical process, one of the molecules absorbs the energy from the light, gets excited electronically, and this excited molecule formation is a primary process, and the reaction of this excited molecule with another molecule is a secondary process. One of the finest examples for photoaddition reaction is Paterno-Bucci reaction. This is a 2 plus 2 cycloaddition reaction which is induced by light. Here, a triplet carbonyl combines with the alkene in the ground state to give a four-membered oxetane ring. As this is given by Paterno and Bucci, this is named after them as Paterno-Bucci reaction. In Paterno-Bucci reaction, a carbonyl compound reacts with an alkene. The carbonyl compound, the carbonyl group is the chromophore, and it absorbs energy and it gets excited to the triplet carbonyl state. This excited carbonyl group interacts with the alkene group in the ground state. It gives rise to a four-membered ring system with oxygen, that is oxetane. In the recent past, a reaction is reported. An aldehyde was taken and treated with a tetramethyl siloxy derivative of alkene. When it was irradiated with light of 280 nanometer wavelength in the presence of benzene as a solvent at room temperature, it got converted into oxetane. It took 4 to 30 hours depending upon the alkyl groups and the aryl groups which is used. What is the reaction mechanism here? Let us look into it. The electrons in the ground state, when it absorbs the light energy, it gets excited and it jumps to the higher energy level. The higher energy level is in the singlet state, in which the two electrons are having opposite spins. It can undergo intersystem crossing to triplet state where the two electrons are in the same phase. This n pi star and pi pi transistor transition occurs either the singlet state or the triplet state electrons can involve in the first stage of the reaction. When this occurs, it induces a diradical. Oxygen has one radical, carbon has another electron. That's why it's a diradical is formed. The diradical which is formed in the excited state, it is unstable. To attain this stage of stability, it donates one of its electrons, and one of the pi electrons over here is donated to this carbon, and the carbon and oxygen bond is formed over here. The remaining one electron moves towards the adjacent carbon, and again a diradical is formed. These two radicals they combine together and forms a bond to give rise to oxetane. Here two pi electrons over here and two pi electrons over here, they have combined together to give oxetane, a four-membered ring system. That's why it is called as 2 plus 2 cycloaddition reaction. Two molecules containing pi electrons have combined together to give a cyclic product, oxetane. They have got added up to each other and give the cyclic product. That's why it is cycloaddition. The two pi electrons of one molecule and the two pi electrons of the other molecule have combined. That's why it is called as 2 plus 2 cycloaddition reaction. In continuation to this, there are other types of photoaddition reactions have also been reported. This has been reported in the Synthesis Journal in the year 2009 by Vogt et al. The carbonyl group adds across CH. In the previous Paterno-Bucci reaction, the carbonyl group added across carbon-carbon bond. Here CH groups gets added across carbonyl bond. I take the molecule with a carbonyl group and a CH3. Here there is CH bonding. It undergo n pi star transition by absorbing the light energy, and it gets excited state, and this excited molecule is represented as star over here, and this excitation gives rise to carbonyl radical. The oxygen radical is unstable. To stabilize this hydrogen along with one electron it takes away, and this becomes OH. Sigma electrons of CH bond, which is in highest occupied molecular orbital, has combined with the single radical of the oxygen to give OH. When these electrons are moved, a methylene radical is formed. Here this is a radical. These diradicals they combine together and undergo cyclization. Addition of carbonyl and CH has occurred to give a pentacyclic compound. This is all about the photoaddition reaction in brief. There are n number of examples available in the literature. In the next presentation, let us deal with other types of photochemical reactions. Till then, have a nice day. Thank you.